it's a combination, not a permutation. And it's basically the same thing except it's called a combination. Let's just do comparison-wise. Combination 20, 6. We just did permutation 20, 6, and it was a big number. What do you get for combination? 38,760. And what was the permutation one? It was 37 million something, wasn't it? 27 million 900. Okay. So comparison-wise, it's a lot smaller number, isn't it? Combinations, there's just a lot fewer of them, and I'll explain why that is in just a second. Okay, but let me do one more comparison, see if you got it. All right, so see what you get, combination 35-7 and permutation 35-7, because I wanted to make a point there about that. The combination 35-7 is pretty big number, 6,724,520. There's a lot more permutation, 35-7. Again, comparison. Yeah, I wanted to mention this one because of what we get here. You may see various things. Mine actually does a pretty good job of displaying it, but somebody may be getting, though, something like this. Did anybody get E10, 3.389, that number, and then E10? No. Maybe. If you did, okay, yeah. What this means is it's the calculator's rendition of scientific notation. What you should write, yeah, is what some display. This is the more proper form, mathematically speaking. Yeah, it's scientific notation. It's E10 exponent of the base 10. Is what that means. It's scientific notation. It's this, which is a large, large number, because you know 10 to the 10th means move this decimal point 10 places back. So that's going to put it 1, 2, 3, 4, 5. Do you have to have a space? Some just put a space there. Yeah. Either way, this is what I'd like for you to write right here, the scientific. But what I was saying is move the decimal point 10 places back. I don't think we'll have enough. There's some more digits, but I don't know them. How many is that? 1, 2, 3, 4, 5, 8, 9, 10. Huh? Yeah, it's either only going to show you the power or an E10. You have to put in the other 10. If this was 9, it'd be 10 to the 9. If it was 13, it'd be 10 to the 13. You see what I'm saying? Huh? Yep. But what I'm saying here is that's a large, large number. Let's see, million, billion, 33 billion some odd.
But you want us to put it down.
Yeah, this is the answer I want. Whether your calculator displays E10, space 10, however it shows it. Show it this way, scientific. Okay. All right, now, why is there so few of those? Let's talk about a specific problem here. Let's say we go to a club N, and we'll say N is Andy, Bill, I'm going to write their names, Kathy, David, and Evelyn. Doesn't really matter who they are, but there's 5 of them. And how many committees of 3 can they form? Similar problem to one we did a little bit earlier, and we're just going to list it out first of all. Got 5 folks and 3 committee members. All right, so give me one committee. ABC? ABC. Can't repeat. And then the other thing is, well, we'll talk about it. ABC is one, ABD is one, ABE is another. Then I could go Andy with Kathy. Now, why not Bill? We're talking committees. Andy, Kathy, Bill. Why would that not be one? Well, Andy, Kathy, Bill is this committee, isn't it? On committees, what's not important? Order. On committees, the order is not important. And that's significant. That's why I'm writing it right there. Okay. The order is not important on these committees. All right. So Andy, Kathy, Bill is not it. I'd have to go Andy, Kathy, and David. That would be a different one because I'd have to get different members somewhere involved. All right. Then Andy, Kathy, Evelyn would be one. All right, then I could have Andy. Let's keep Andy here going. Andy with David and Evelyn. That would be something different. There's nothing Andy, David, Evelyn there. But I think that's about it, because anything else I have with Andy is just going to be a rearranging. If I do Andy and Andy with Evelyn, and who am I going to put? Bill? No, I've already got that one. So that's it for Andy being the committee. So I'm going to have to go to Bill here. And then Bill, Kathy, David would be different, wouldn't it? And Bill, Kathy, Evelyn would be different. And then Bill, David, Evelyn. See what I'm doing there? And then that's about it for Bill. Anything else would be... That leaves us one more. Kathy and David and Evelyn. Altogether, 6, 10. 10 committees. I do that because here's what I want you to try on your calculator. We're just talking about combinations. Do combination 5, choose 3. What do you get? Not by coincidence, you get the same number as we got there. Yeah, it turns out this is what's the key ingredient here. The order not being important. You're going to use a combination whenever order is not important. What happens is the combination, what it does is it doesn't count those just rearranging. Like a combination doesn't count Andy, Kathy, Bill. It just doesn't do it. That's what a combination's job is. It doesn't count those repetitions, because if I counted those repetitions, that would be a permutation. The rearranging, I'm sorry. That would be a permutation. So that's how a combination differs from the things we've been talking about. The order is not important on combinations. In other words, you use combinations when the order is not important. Okay? Using combinations when order no important. Okay? Committees is one such example of combinations. Committees are always going to be combinations. All right? Let's see. Let's try another one here. All right, so let's do another club one here. this club is going to have 13 men and 17 women. Number one, how many committees of 6 can they form? Now, what I'd like to do here is tell you there's a question now that you have to ask. Before, it was just all blanks all the time. But if it's a combination, we can't use the blanks. So the question becomes, when we come to a problem now, is it a combination or is it blanks? Because if it's a combination, I've got to use combination. If it's blanks, I use blanks, okay? So that's kind of the question you have to ask yourself, is it a combination or blanks? And really it just matters, it boils down to, is it a combination? And it's a combination if what? If, okay, committees is one example, but it's if the order doesn't matter, right? It's a combination if order doesn't matter. So just think, about it. I mean, committee of 6, I mean, you think, if I have A, B, C, D, E, F committee, if I go F, E, D, C, B, A, is that the same thing? Yes, it is. Same committee. Order doesn't matter. So yes, this is a combination. Committees will always be combinations, not the blanks. It's the combination. Committees will always be combinations, all right? Now, it's a combination, what? I want a committee of 6. Well, the first, just like in the permutations, I didn't write it all out, but the first one is how many there are to choose from. That's the first number in the combination. How many are there to choose from here? Well, we've got a club with 13 men and 17 women. That's 30 people, isn't it? Don't I have 30 to choose from here? Can be any of those 30? The second number is how many at a time I want. How many of these at a time do I want? I want a committee of 6. Doesn't matter in this one. Now, we'll do another one where the male and the female men and women will make a difference which is which, but no, not in this case. It could be any of those 30. We could have, 3 men, 3 women. We could have 2 men and 4 women. It doesn't matter. How many does that give us?